Okay, boys and girls, today we're going to continue working with multiplication and equivalent fractions. And at the top, we can see the target says, I can use the area model and multiplication to show the equivalence of two fractions. And here we see an area model, and it's showing us 2/3. There are three sections, two of them are shaded red. And we're going to talk about how we can use, again, multiplication to show how two fractions can be equivalent. So let's say I decided to show 4 times the number of fractional units. I could start by drawing 1, 2, 3 lines, and I've taken each unit and divided it into 4 smaller units. So we know that there were 3 sections to start with, and now we have 12 sections. And where 2 were shaded at the beginning, now we can see that 8 are shaded. Using the area model, we can now see that 2/3 is equal to 8/12. But we can also use multiplication to show that 2/3 equals 8/12 by multiplying the numerator times 4 and multiplying the denominator times 4. And when we do that, we get 8/12. Okay, in this example, we have the fraction 5/6 here, and I want to give or represent an equivalent fraction here that's got a denominator of 12. And I want to try to find out what the numerator will be for that fraction. Here I've got an area model that shows 5/6 already shaded. When I think about the relationship between 6 and 12, I know that 12 is the double of 6. So down in my area model, I know that if I draw a line through the middle, I've doubled the number of sections. So where we had 6 altogether, now we have 12. And I can now count the number of sections that are shaded. And we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 5/6 is equal to 10/12. And when I think about what I've done, I've doubled the number of sections. So to show that with multiplication, I know that I would take 5, multiply it by 2, and I would do the same thing with the denominator, 6 multiplied by 2, to also show that 5 times 2 is 10, 6 times 2 is 12, and again we're showing the relationship between 5/6 and 10/12, and we can see that they are equivalent. So we've doubled the number of units to make 12ths. We have twice as many units in the whole and twice as many units selected. But we know that the parts are only half as big because there are 12 of them. They're half the size of the 6ths. So the area of the fraction stays the same, but the number and size of the units change. The number of units increases and the size of the unit fraction decreases. In this example, we're starting with 2 fractions, and we have 3/4 is equal to 6/8. And before I do anything, before drawing an area model, I want to decide, first of all, if this number sentence is true. Does 3/4 equal 6/8? I can first check to see, using multiplication, I can write 3/4 and then add my line here and then write 6/8. So 3 times 2 is 6, so that works. And I know that whatever I do to the numerator, I've also got to do to the denominator. So 4 times 2 is 8. So I've checked with multiplication, and now I know that 3/4 is equivalent to 6/8. That number sentence is true. To show that with an area model, I would just draw my area model. I would divide it into fourths. I would shade 3 of them. we were multiplying times 2, which means I was doubling the number of sections. To do that, I just draw one line through my area model. And then when I count the number of sections, I have 1, 2, 3, 4, 5, 6, 7, 8. And there are 1, 2, 3, 4, 5, 6 shaded. So I've used multiplication and drawing the number or the area model to show that this is true. Here's sort of the same idea. This time I'm looking at 3/4 is equal to 6/12, and I want to check to see if that number sentence is true or false. And as we did before, I can set up my first fraction, 3/4 is equal to 6/12. So I'm going to take my numerator and my denominator, and let's see. In order to get from 3 to 6, I know I have to multiply my numerator times 2. That does give me 6. But the rule says I have to, whatever I do to the numerator, I've got to do to the denominator. And so if I multiply 4 times 2, I get 8, not 12. So using multiplication, I'm able to see that this number expression, or this number sentence, I'm sorry, is false. I can also show that using the area model. Divide it into fourths, shade in 3 sections. And if I'm multiplying times 2, that means I'm doubling the number of sections. And I know when I count them, 1, 2, 3, 4, 5, 6, 7, 8, I don't have 12 sections. So again, this doesn't work out. So this number sentence is false. In this example, I'm starting with 3/5, and I want to write a number sentence using multiplication to show that two fractions are equivalent, and I want to do that before I draw the area model. So I'm thinking about all the things that we've learned, and I know that for the last couple of days we've doubled, we've tripled, and we've even quadrupled the numerator and the denominator, which means we multiply the numerator and the denominator by the same number. So since I'm not being told what equivalent fraction I have to write, I can just choose one, and I'm going to take my fraction, 3/5, and I'm going to multiply the numerator and the denominator each by 3. And that gives me 9/15. So using multiplication, we're saying that 3/5 is equivalent to 9/15. Now I'm going to show that using all of my information from my number sentence. So I'm going to create an area model that shows 3/5. And I'm going to shade 3. When I look back up at my number sentence, I know that I multiplied the numerator and the denominator by 3, so I tripled the number of sections, and to do that, there's my 2 lines. And so now when I count the number of sections, I count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And I know that 1, 2, 3, 4, 5, 6, 7, 8, 9 are shaded. So I've used my number sentence, I've used multiplication, and the area model to show that 3/5 is equivalent to 9/15.